So, good evening, everyone. So, just a clarification. Here, when I said that n square addition, I forgot to give you a disclaimer that in actuality it is n into n minus 1. Okay, but however, as we are discussing, as the length n is increased, so we can roughly tell that this is n square. Okay, so please keep it into the mind. Actual is n into n minus 1, but when capital N is higher, so we can approximate it to as n square. Okay. Now in our last class, we have looked into this DIT-FFT architectures. So what are the key points over here? If you see, the input, it was in the bit reverse fashion. Output, it was in the normal order. Okay. Then we had this butterfly architecture. Then what happens at the lower signal transmission line, we have this, or transmission path, we have a multiplier of -1 and twiddle factor. It is being multiplied just before the butterfly architecture is being implemented. Okay, before these cross paths. Okay. Another important thing was that initially we do the, say, 2-point DFT, then we go for the 4-point DFT. If it is an 8-point DFT, then after performing 4-point DFT, we go for the 8-point DFT. Okay. Now let's look into DIF-FFT. So the architecture, it remains the same with subtle differences. What are the differences? The differences is that let's first take the 2-point DIF-FFT. So X0, it is in the normal order. Input is in the normal order. Output is in the bit reversed order. Then we are having this butterfly architecture. Okay, the lower path, it is having a multiplier of -1, just like in the previous case. The major difference over here is that in the previous case we were having twiddle factor at this location in DIT-FFT. However, in DIF-FFT we are having after the implementation of the crossover. Are you getting my point? Now, as we go towards this higher DFT, 4-point DFT, in the DIT-FFT, we were first doing the 2-point DFT. Okay. Here, we will be doing the 4-point DFT. Okay. How to make the crossover? The rules remains the same. The rules remains the same. Then, after the completion of the 4-point DFT, we will be going for the 2-point DFT. Okay. Then if you go for the 8-point DFT, initially we will perform 8-point DFT. Then we will perform 4-point DFT. Oh, sorry, FFT. Then we will perform 2-point FFT. So if I tell you, compare the DIT-FFT and the DIF-FFT, you should be able to do the comparison. Apart from that, you have to draw the butterfly architecture showing the differences. Okay. So the for the 2-point DFT you will show, and then you can make it in this fashion, this block diagram fashion. Initially 2-point DFT, then 4-point DFT, then if you want to show the 8-point DFT, then you will repeat this one at the bottom over here, and then from there you will be showing it as the 8-point DFT. Okay, for both the thing, right? So this is the difference. Again, coming to this tabular method, the method remains the same. The tabular method W8N, then we are having the ones in the top signal paths, and at the bottom signal path we are having the total factors. Then you get the output at the stage 1. This is the output for the DIF-FFT. Then what we get into the stage 2 where we perform 4-point DFT. Again, in the 4-point DFT we segregate the points into 2 parts. So from the half, the top parts they will be having value of 1, and the lower parts they will be having the total factors. Okay. Similarly at the bottom 4 cases, and again you will be getting some output. Now you will be using this output and calculate the stage 3 thing. Okay. Now once it is there, again if you see the input, it is in the normal order. Output, it will be, if you look into the output, it is in the bit reversed order. Okay. Then IDFT, if you perform, input would become the frequency components, it would be in the normal order. Okay. Then instead of total factor, we will be using the total factor conjugates. Okay. Then stage 1, stage 2, stage 3 output you will be calculating, and then at the stage 4, whatever the values you will be getting, you will be dividing it with 1 by 8. Okay, because this is an 8-point DIF-FFT. Okay. So now I will ask you to perform the thing. Now perform the same numerical. Now before going into that, if you look into the methodology of this FFT, so what happens over here is that uh, there are basically 2 methods. So first we take for the IDFT, we take xk as the input, which is in the normal order in the DIF-FFT. In the DIT-FFT, it is the bit reversed order. Then we take the conjugate of the total factor, and then xn as the output. It is basically in the reverse order in DIF-FFT, and in the DIT-FFT it is in the normal order. The second method is you find out the conjugate of the frequency component. Okay. Then perform FFT to get x dash conjugate n. Then you do the conjugate of x dash n to get x dash n. Then you have to calculate 1 by n to get xn. So over here, if you see, you are finding out the conjugates 3 times, which is more tedious as per me. So I prefer the DFT 1 method for the computation purpose. Okay. And here the actual number of these computational these things, complex multiplication n square it is given, and complex addition n into n minus 1. And over here also complex multiplication, it is n by 2 log 2n, and complex addition is n log 2n. So these are there. Okay. So with this, I will ask you to do the 2-point and 4-point FFT for xn equals to 2. Okay. Then after you are done, then yeah, so we can have another numerical if time permits. Okay. So please do it. If you have any questions, you can ask.